It's in Florence.
Yeah. Like he'll be gone when we leave here for Christmas break or whatever, and Thanksgiving break, he'll be gone.
So everybody has their new exercise sheet. I think I gave everybody the new exercise sheet, right? So this is essentially sort of the best of. Essentially, it's a best of collection of the homework from chapter 6 and the end of 5. There are other homework problems. There are other homework problem types that I haven't included, and if I haven't included them here, in some sense, it's me saying that problem's kind of stupid. But I mean, we still should do them, but some of them are just, I don't know. There's almost nothing to do. It's hard for me to see how it's a problem. So, all right. So exercise 1. What did you guys do?
X equals 360.
X equals 360. And now how did you get that?
I'm trying to learn off the
You just guessed numbers. Started with 1.
I got it right. I was trying to learn how to do the problem off Socratic, but
Socratic.
yeah. But I couldn't figure it out, so I just wrote down the answer.
Well,
Is it the right answer though?
yeah, I mean, he's right, but why?
Because you gotta multiply inside by 30 to find common denominators.
I hear multiply by 30.
To find common.
So you say make a common denominator? See, there are 2 different ways we could go here. The one way would be to just multiply the equation by 30. The other way would be to find a common denominator. They're very closely related. I'll make a common denominator. So the first becomes 6x over 30, right? And then minus 5x over 30. Now we've got a common denominator. So that's x over 30 equals to 12. So x is equal to 12 times 30. So x is equal to 360. And of course we could check, right? Check it. So like 360 over 5 minus 360 over 6 is 72 minus 60, which is 12. So, hooray. Now, I would point out, this just came to me, another way you could do this problem would be to multiply the problem by 30. Like if you multiply this by 30, you get 6x minus 5x is equal to 12 times 30. See, because like 30 over 5 is 6, and 30 over 6 is 5. So I get that, which gives me x equals to, I mean, that's another way you could do it. You did that? Okay, that's good. Okay, how about the next problem? How are we going to do this one?
Multiply all sides by s.
You put s squared.
I heard a multiply by s. I like that.
It'll be s squared plus 11. And then I brought the 12 over before I multiplied it by s. And did 0.
So you got s squared plus 12s plus 11 equals 0. Now this is a quadratic equation in s, which means we can solve it, right? So we factor
S plus 11, s plus 1.
Very good. So that tells me s is equal to minus 11 or minus 1. Yep. Now, we should check our answer, right? So, check it. Minus 11 plus 11 over minus 11 is minus 11 minus 1, which is minus 12. Hooray. And minus 1 plus 11 over minus 1 is minus 1 minus 11, which is also minus 12. So, good. It's all okay. Now, we will eventually get to the point today where the checking the answer actually rules out some of what we think we found. We're not there yet, but we'll get there. How about this one? What are you guys going to do? What did you do? usually students tell me to cross multiply. So cross multiply gives me 2 times z minus 1, 1 times z plus 6. It's cross multiplying. And of course, this gives me distributing 2z minus 2 equals to z plus 6. And I'll subtract vertically. It's happy. See? I did the vertical subtraction. Okay, good. So z, I was looking for the affirmation. Z minus 2 is equal to 6. Aww. Man. 6. So z equals 2. Oh, I'm sorry, I missed opportunity. Vertically, let me vertically again. So z equals to, I got z equals to 8. Do you guys get z equals to 8? Excellent. Does it check?
Yes, sir.
Okay, I'll trust you guys on it checking. And how about this one? Got there yet? So you're saying cross multiply? So 4 times x plus 1 equals to 5 times x. Yeah. So distribute 4x plus 4 equal to 5x. I will vertically subtract 4x from both sides. So that gives me 4 equal to x. Oh, guess we're done. At this point, exactly, this is what I said yesterday when I was working this in the other section. I was like, I got done with all these steps, and I was like, wait a second. Like any reasonably open-minded person could just look at this problem and go, 4, right? 'Cause I look at the problem. I mean, I need the top to be 5. I need the bottom to be 4. So the top is 1 more than the bottom. Yeah, x equal to 4, right? I mean, it just, I would not assume a student cheated here if they just wrote down the answer without work, you know? I mean, it's definitely a significant portion of the population of students who takes this who'll be able to guess it here. But yeah, x equals to 4. All right, now we got to the fun part. So I need to remind you of some things going forward. Remember the radical stuff? Maybe not. So, fun fact, the 2nth root of x to the 2n power is the absolute value of x, right? And that is equal to x if x is greater than or equal to 0, right? Now, if you look through the problems that I've given you on this sheet, in every one, I have added like a little disclaimer, hey, assume the variables are non-negative, assume the variables are positive. That is in the interest of us not having to worry about absolute value, all right? And your textbook does the same, so it's not just me making it easier, it's nothing to sneeze at. Let's see here, so. Anyway, so, sorry, that was horrible. 2n plus 1, x to the 2n plus 1. In contrast, if you take the odd root of a odd power, you just get x. So, for example, the square root of x squared, generally speaking, you got to have the value of x. But the square root of x cubed, guess what? It's just x. Square root. No, cube root. Cube root. So, long story short, here's the summary. If x is positive, or non-negative rather, then the nth root of x to the n, which is, by the way, x to the n raised to the 1 over n power, is just equal to x. So if we want to get rid of like 1 over n, if we want to get rid of an nth power, we can raise the equation to the 1 over n power, right? Or vice versa. We can take x to the 1 over n and raise it to the n power and also get back x. These are inverse operations, okay? Now, what more do I want to tell you? I want to tell you about how minus works. What's that? Well, yeah, a little bit. So like square root of, if we had square root of minus AB, it's really not equal to minus the square root of AB. So like for this to be true, we'd need that minus AB was greater than or equal to 0, which then would say that this AB is less than or equal to 0. And then we'd have the square root of a negative number possibly, and then that would be bad, because we don't do that in here. Until the very end of the course when we do. Chapter 7, the quadratic equation. There we do complex numbers, all right? But that's. So in contrast though, if you had the cube root of minus a, right, you could write that as the cube root of minus 1 times a. And in this context, you can do it. You get cube root of minus 1 times the cube root of a. And the cube root of minus 1 is what? How many votes for 1? How many votes for minus 1? Hey, wait a minute, you voted for both. Huh. Well, you just got to register, and you got to register in 2 states. But I feel like you should cast your vote for Trump in the state where Trump's going to win, and you could cast your vote for Biden in the state where Biden's going to win. That way, both your votes count, and then you'd be truly moderate. I mean, you might. Well, we're talking about casting 2 votes. I mean. Speaking of voting, what? You got to go home to vote Tuesday? More power to you. Very. Who am I going to vote? I already voted. Who am I going to vote for? Who? I'm not voting for nobody this year. Well, I think I told you guys already. I was on the fence, but then when it didn't I already? Didn't I tell you guys before? I was on the fence before, but once I found out that 50 Cent supports Trump, like it just pushed me over the edge.
Yeah.
I voted for Biden.
You voted.
Dude, I can't vote for that guy. He can't remember his last name half time.
I do feel bad for
I'm guessing number 5,
that.
negative 7x, according to my calculation.
What's that? Negative what?
7x.
Negative 7. Yes, you're right.
Negative 1 win or 1?
Yeah, the cube root of minus 1 is minus 1. So the cube root of minus 1 is equal to minus 1 because minus 1 cubed is equal to minus 1.
You know what we're up for president?
All right?
Ben Shapiro.
Ben Shapiro.
You know who it is?
Uh-huh, yeah.
Dude, I'd vote
See,
Ben Shapiro.
Ben Shapiro is interesting because I heard people talking about Ben Shapiro for a while, and I never really seen any clips of him. So I was thinking he was this old lawyer who's done like, you know, been involved with like I think I was confusing him with the guy who was a lawyer for OJ. What's his name? I don't remember. But
Wasn't he in the Kardashian family or something?
oh, I don't even know. But
Have you watched any of Ben Shapiro's videos?
He knows his stuff and will get hold of somebody.
Who's Ben Shapiro?
You don't know who Ben Shapiro is? I'm gonna send you one of his videos.
Okay.
I think
Wait,
he.
is he that guy that like
Watch it in
everybody
private.
just they all question him like and
He's up on the stage.
yeah
Yeah.
yeah and he's like really
He has the.
really intelligent.
He has the rare feature you rarely see anymore, which is a person who believes what he says and says what he believes, and doesn't back off of it.
Dude, whenever
So
he was on stage that day,
yeah.
he didn't have no papers, but he was just sitting there answering questions. Somebody like trying to get at it, and he just started going off on the top of his head, just like
he
very intelligent person.
that is true. All right, so yes. So my point, guys, if I can do math again, is when we have a cube root, we can pull a minus out. All right. We cannot do that with like a square root or a fourth root, but if we have an odd root, you can pull out a minus. Okay, so that's just something to remember. Okay. So all of that was just to motivate my first move over here, which is minus the cube root of 343x cubed. Now the next thing that I should mention is, if we have the nth root of AB, it's the nth root of A times the nth root of B, provided n is odd or AB are greater than. So if AB are greater than or equal to 0, we can safely break up the nth root into a product of the nth roots, like even if n is even. But if n is odd, then we can just do it, because we can take the odd root of a negative number. It's okay. But anyway, so this is minus the cube root of 343 times the cube root of x cubed. And how do you calculate the cube root of 343?
With calculator.
With a calculator? So that's an important comment. Do you guys know how to calculate a cube root with your calculator? Can you do that?
Photomath does well.
Photomath does it well.
Ben Shapiro's good.
But I prefer we not use photomath on the quiz.
I forgot, to be honest.
Dude, you just hit the shift and it's got the little cube root button.
Yeah, there should be I don't have my calculator on me, but
Where is it at? You need some help, bud?
No,
your phone.
All right, I was just checking on you.
Hey, go follow me on Twitter. I just downloaded it.
I don't even have to.
I never have one. Somebody was like,
Twitter. What do you guys?
Who's bringing on board?
oh gosh, I know.
All right, let's see here. So, fun fact: 7 cubed is 343. So that means that the cube root of 343 is the cube root of 7 cubed, which is just 7. Yeah. So this is minus 7, and the cube root of x cubed is just x. So, as Hayden was telling me about 5 minutes ago, minus 7x. Yep. All right. Let me find my eraser. Oh, yeah. You got it. I really don't, I honestly don't understand how it ended up being Biden. Like, it seemed to me like the other candidates were like stronger.
Yeah, it's like Bernie.
I mean, I feel
They
like,
didn't have very long.
I feel like Bernie Sanders would really have been much more trouble for Trump.
Yeah, probably.
Same for last election. Like last election, I think, I'm not sure Bernie, I think Bernie might have won last election. I don't know.
I figured Hillary was going to come in it again. I figured, but she gave Trump a lot of.
I don't know.
Yeah, I don't think I have a shift button on here.
But it is important. You guys need to figure out a way to calculate like the cube root for the next quiz. So make sure that's something that you can do. Oh. Where did my, where's my,
Dude, Ben Shapiro's 36. He could legally run for president. 1 year over there. Got this.
what on earth?
I'm gonna send him
Somebody's
a very detailed email.
I like your beliefs.
other struck,
I like your beliefs. If not, I'm gonna throw like vegetables at you.
next Thursday? Next Thursday sounds right.
Dude, he knows. I promise you, Ben Shapiro knows more than Trump, Hillary, and Biden.
This is fun. Let's see here. Yeah.
He probably does. Though.
Latavia, you're here, right? Yeah. Oh, oh.
He went to Harvard. I mean, he's 17.
Jason's here. Kennedy's here.
At the age of 17, he became the youngest nationally syndicated columnist in the United States.
I don't know, honestly, I think it should be nice.
Harvard Law School. It's just a beast.
Just because.
All right, so
Yeah, that's kind of dull. You can go to the farm, but you can't. Beer, cigarettes,
Do
gin.
you smoke cigarettes, Peyton?
No. Does it dull look like I smoke cigarettes?
Be careful, Austin. Don't put your throat towards the shower head.
That's what they be saying on the commercial.
Hayden looked like he'd light up a 100 and eat it down in one pull.
Be careful, Austin.
Oh yeah, we got them.
What's wrong with cigarettes?
all right, let's try to do these ones.
I'm just catch you a man,
Don't they tell you guys not to be a quitter? What's wrong with you guys?
You have a Twitter?
No, I said you shouldn't be a quitter, right?
I'm not a quitter. What do you mean? Dude, how much money you think?
Oh, thousands. Dude,
I
like,
can't
8
say-
years, I'm probably at a solid like 5,000 by now. Like this.
Oh, I calculated it, in 1 year, I spent pretty close to, it was like 3,000 or 4,000. One year.
I'm sure that's.
I don't honestly don't know how much I spend.
I have a lot of money right now making things like.
Oh, dude, if I would have never started books, I'd probably could buy
All right.
a car. I could buy a 2013 Challenger.
Let's do these.
That's a little lawyer.
Because you think it started off at school, then what enjoy.
All right, so we're asked to rewrite the expression without using fractional exponents. So how do we get rid of the fractional
Oh,
exponent?
wouldn't that be 5, like the 5 where the 3 is over there? I forgot what it's called. Over here on the last problem we
I
did.
just had a baddie compliment.
Put the 5 right there and then put the A4, B4 up underneath it.
So yeah, put the 5 as the index of the root. So it's like, yep, this is, there you go. So that one is, so guys, that is all there is. That is all there is to this one, because you're just asked to rewrite the. You guys got to stop talking. I can't hear myself. So like the fifth root of a to the fourth b to the fourth is a to the fourth b to the fourth raised to the 1/5 power, and that's all there is to it. I mean that's what the question asked, is for us to rewrite it not using fractional exponents. So there you have it. Now this one, we're supposed to simplify this. So what are you going to do? Multiply, yeah, so 3/4. What's 3/4 plus 5/8 is the question. A number? Seems safe to say. That's 6/8 plus 5/8, otherwise known as 11/8. Right? And if we are not allowed to write it using fractional exponents, then how do we have to express this? What is it? We could say that that's 4 to the what? 4 to the 11th power and the 8th root of that. What else? How else could you express this number without fractional exponents? You could also write this. Don't ask you. This is also the 8th root of 2 squared to the 11th. Because 4 is 2 squared, right? So another way you could write this one would be the 8th root of 2 to the 22 power. So there's a few different reasonable answers for this problem. I think exercise 8 is actually a little bit easier, right? Because when we have that division, how does it work? We do what? 7/4 minus 5/4, right? 7 to the 7/4 minus 5/4, what is that? What's 7 minus 5? 2, right? Yeah, 2. So 7 to the 2/4, that's 7 to the 2/4, right? Which is 1/2, right? 7 to the 1/2. So we could write that as the square root of 7. There you go. Now, how about this exercise 9? So I would first of all say, well, that's the square root of 1575 times the square root of x to the 4th, right? But what is that? That we could write that as the square root of 1575, whatever that is, times x to the 4/2. In other words, we've got x squared times whatever this number is. Well, that's the square root of 7 times 225. So you could rewrite that as, 15 x squared times the square root of 7 for what it's worth. Because 225 is 15 squared. And I think anybody can just look at 1575 and go, oh, well, that's obviously 7 times 225, right? I mean, come on, like, duh. No, I mean, I worked this problem yesterday. The number's still stuck in my head. Don't ask me my age. I don't know that. But I do remember that that's 7 times 225.
You're like 38.
38? Well, thank you.
Okay, then 42.
I've offended Kennedy. Now she's leaving.
Yep, I'm gone forever, never come back.
Aw. You better come back.
We gotta go get athletic training.
I need someone to...
Oh, I got it, yeah, I forgot about that.
Wait a minute. You're leaving me for athletics?
Yes.
That's so much worse.
Okay, yeah. I'm
Really,
not
this right here,
Oh,
I gotta get turned this in by Thursday.
all right.
Thursday at 8 a.m. I got
Fine.
Let them go.
Okay. All right, okay, so this one, so we do square root of 80, square root of a squared, square root of b. The square root of a product is the product of the square roots, provided that the quantities involved are positive. We don't have to worry about the absolute value issue. We don't here. And so square root of 80, well, 80 happens to be 5 times 16, which is 5 times 4 squared. Yeah, exactly. So this is, well, other way around. 4 root 5, but you got the right idea. 4 root 5, a root b. So there you go. Now, as far as the test is concerned, if you wrote square root of 80 rather than 4 root 5, I'd be fine with that. Like, this is not the reason I'm going to fail a student in this class, right? Like, not inability to write square root of 80 as 4 root 5. That's not really what I'm after. Now, if you can't factor, if you're completely lost with factoring at the end of this, then I would be much more inclined to, ask you to take the course again. But hopefully that won't happen. So how about this one? Square root of 45 times the square root of 60. Of course, you could use your calculator, right? Like you could just straight up go, well, that's the square root of 45 times 60, But if you look at that number, that's 15 times 15, so it's 15 squared times 3 times 4. So that's actually 15 times 2 times, 30 radical 3. 30 root 3 is that number. Again, whatever. I really can't grade much on that kind of calculation because you guys have calculators that just do that anyway. So it's not especially interesting or fair to me. See, the reason I really don't want to test on this is I don't think it's fair to test on that when some people have calculators that will just do it and other people have calculators that won't do this exactly, So.
What's that supposed to mean? Joke's on you, I'm smart on this thing anyway.
You guys talking smack against each other or the calculators? I lost track.
I hope that one day I'll be smarter than a calculator.
Is it bad every time I come here, I have negative energy?
You have negative. You say every time you come in here, you have negative energy.
I get angry, I don't know why.
You get angry.
Yeah, they want to go on.
I think it's.
I don't know, this
After this class. Huh?
I can't answer the class. I've got to, I gotta get that tutor, but I won't take long, and then I have to go, get signed up for classes for next semester. But maybe not tonight, but later this afternoon.
All right. So the
6 o'clock maybe.
if I can find a piece of chalk that's not broken. So the examples I'm about to do, guys, they're a little bit different. I'm skipping over a few, and because I want to look at the ones that involve solving with radicals. So these are the more towards the end of chapter 6, actually. But I think it's important to start this because, these they're related to the things we've just been doing, but the thought process is a little bit different. So square root of 4x minus 17 equals to 1. Can we solve this equation?
Wouldn't you just square each side and then get 4x minus 7 equals 1?
So you say square both sides. Does that make sense to square an equation? Yes, I think it does. So what you're saying is that you can multiply both sides of the equation. We multiply the left side of the equation by the square root of 4x plus minus 17, right? We multiply the right side of the equation by 1. That's reasonable because the equation is assuming those are equal, right? So we're multiplying both sides of the equation by the same thing. It makes sense to square an equation, you're right. And that's a good move here because the square root of the square is what? The square of the square root is just whatever's inside, right? Yeah, so this is just 4x minus 17. Yeah, 1 squared is 1. So 4x equals, 18, right? And, yeah, 18 over 4, right? Sure. And, again, I would still count that, right, if you put 18 over 4 as the answer, but yeah. So, and then, we can check our answer here. Does it work? Square root of... No, I wouldn't do that. Let's see here. I don't care for those mixed numbers. Let's see here. They're bad news. Let's see here. So this is 18 minus 17, which is square root of 1, which is 1. So as you can see, the solution is in fact a solution. Yeah. All right, now that one was not too bad. Let's work one that's kind of worse. Exercise 23. Let's try this on for size. X minus 8 equal the square root of x minus 6. Can we solve this one? I mean, I think we should start the same way you said we should start the last one. I think we should square the equation. So because that'll get rid of the radical is the point, right? So x minus 8 squared equals the square root of x minus 6 squared, which is what? That's x minus 6, right? But on the other side, we get what? We get x, FOIL it out, right? X squared minus 16x plus 64 equals to x minus 6. How do you solve an equation like that? You should all be able to do this one.
You bring the x over and make it a 15.
Uh-huh.
Then you bring
Well, minus
the-
x.
17. And then you bring the 6 over and make it a 70.
All right, so we basically rearrange it so that it's a quadratic equal to 0. And the reason we want to do that is so either we can use the quadratic formula if you like that. I don't recommend it. Or you can complete the square. I also don't recommend it for this problem. Or you can factor it. I think
I'd say negative 7 and negative 10.
so. X minus 7,
X minus 10.
x minus 10. So from that we can see x equals to 7
X equals 10.
or x equals to 10. Right. Now at this point we have to check and see if those are actually legit solutions or not. 7 works. Well, let's see why that is. So x equals to 7. So we have 7 minus 8 equals the square root of 7 minus 6. So this is minus 1 equals the square root of 1, which is 1. Uh-oh. Oops. Minus 1 equals to 1. This is, no. Flag on the play, right? Oh, yeah, call.
So if we wrote down,
Oh, that's okay.
if we wrote down x equals 7 or x equals 10, you would.
I'd have to take off points if you put out an x equals 7 as a solution. X equal to 7 is not a solution. So this shows you that, in fact, x equals to 7 is not a solution to x minus 8 equal to the square root of x minus 6. So in this case, x equals to 7 is usually called an extraneous solution. Well, let's check x equal to 10. Did that one work? So we've got 10 minus 8, which is 2. And we got this, square root of 10 minus 6, which is the square root of 4, which is also equal to 2. So you look at both of these, they match up. Hooray. Yeah.
So the answer is x equals 10.
Yep, the answer is x equal to 10. So
You go with the 7, just kind of throw it out.
it's, yeah, and so how did that happen? How did we get an extra solution? Like, how did that happen?
God wanted it to be.
What's that?
Like God wanted it.
It's the way God
Good
wanted
answer, Hayden.
it. I've been given the Sunday school answer. So by the sovereignty of God, Hayden claims. I mean, I wouldn't argue with that, but
So if I wrote that down, it'd be right.
well,
You just said
No.
you wouldn't argue it, you can't take it back.
I wouldn't argue with it, but I'd still take off the points.
How much?
Well, it depends on how much I laughed. But so
How much is Bible verse, like an inspirational Bible?
so here's a different problem. 8 minus x equaled the square root of x minus 6, right? How would you solve that problem?
That would be 7.
Square it, right? So my
Another word worth these?
So my point to you, what I'm trying to say here is that this problem gets you to the same quadratic equation.
That will be 7 and not 10. Correct?
Yep. So x equals to 7 or x equals to 10, it appears. But when you try it out, you'll find out that this one is the solution and that one does not work. Because 8 minus 10 is equal to minus 2, which is not equal to the square root of 10 minus 6, which is equal to square root of 4, which is equal to 2. So here's the deal.
So you just kind of throw whichever one away that doesn't work.
Right, but I'm asking you more like a philosophical question. How did we get an extra solution? Like, what step in our work is because usually we make steps to an equation and we don't like all of a sudden find out, oh, instead of having one answer, we got 3. Like, that doesn't happen. You know, we divide, we multiply the equation by a non-zero number, stuff like that, right? We add equations.
And you go with square first time.
Is the squaring is the culprit. See, because when you square the equation, you're sort of necessarily losing track of the sign. So like squaring sort of eats the minus. And if that minus means that there's no solution, then you can accidentally sort of adjoin solutions by squaring, is what happens. And I mean, it can even happen when you've only got just one thing. Like, for example, if I had minus 3 equals the square root of x plus 2, I square both sides. I get 9 as x plus 2, right? So x is equal to 7. Except, is it true? Is x equal to 7? Is that the solution to this problem? If I take the square root of 7 plus 2,
No, you're gonna be a negative 30.
I get square root of 9, which is 3, which of course is not equal to minus 3. And the way that happened,
Would that mean x would be equal to negative 11?
oh, so that's a good question. So here's the question, guys. If I have a problem like this, minus 3 equals to the square root of x plus 2, is there a solution?
X equal negative 11?
Oh, minus 11 doesn't work. The square root of minus 9 is 3i.
Yeah, that's probably no solution.
Right, there's no solution. And we could understand this graphically. Like, I like to think about these kind of problems graphically. So y equals to the square root of x plus 2. What's that look like? Let me make myself some room. I'll think about it over here. I mean, because I'll tell you, when I first saw some of this stuff, I found it very disconcerting. It seemed like sometimes I'm squaring the equation and I get 2 answers, and they both work for some problems. Other times, I square the equation and I get no solutions at all, like with that one. Other times, just one of them works, and it's just like, it seems also ad hoc and random. But you can understand these things graphically if you want to. So this one, we're trying to solve minus 3 equals the square root of x plus 2, right? So graphically, y equals minus 3 is like this line, right? Y equals to the square root of x plus 2. This is the square root graph shifted 2 to the left, right? So I go 1, 2, it's something like this. So, looking at this graph, there's no intersection. There's no x for which this is equal to that. These graphs are disjoint. There's no solution. That's the graphical understanding of it. But there's a more basic understanding, which is just that the square root of blah is greater than or equal to 0. So if you have the square root of whatever is equal to a negative number, game over, no solution. You don't have to think about it more. So as we look at the exercise sheet, like one of these is like that. Exercise 22, you can just look at it, Square root of x plus 7 equals to minus 2. Answer, no solution. Because you can't have the square root equal to a negative number by our definition of square root. Now, there are other problems in your homework which concern the principal root versus the... So I have to talk about this a little bit because your homework brings this topic up, and it's good to talk about. So if we have... Let's see here how to say this. For example, if x squared is equal to 16, then x is, let's say, quote unquote, a square root of 16, right? Well, that's the thing is, this has, what are the solutions? So we have x is equal to plus or minus 4, right?
Why wouldn't you just square root 16?
You could do that, but when we do that, but what am I leaving? Exactly, but what am I leaving out there? The other possibility, right?
Oh, so you're just trying to give more possibilities.
What I'm saying is that the square root problem has two answers. It doesn't just have one. So there's terminology. So the terminology is this. The square root of 16 is the so-called principal square root, or principal root. I'll just say principal root of 16, or principal square root of 16. And then the other square root of 16 is minus that. Now, I hesitate to even say that in here because I want to dogmatically assert that square roots are non-negative. So I don't even really like to have this discussion in here, but I have to because your homework has brought it up. Like there's some homework problems asking you to find the principal square root of the number and also the other square root or the negative square root.
I've always done that on the bottom. Like, you just put the plus minus along with it.
Right, yeah, we can do that. That's totally fine. And the logic for that is that this factors in the difference of squares, and so we get the plus and the minus of the principal square root solution, right? And that's still true when we complete the square and such. So we're nearing the end of class. I think I can do another one. Let's see here. But you know what? I'm going to save it for when Kennedy and Miss Anderson are back. And so in the time that remains, let me talk to you a little bit more about some kind of neat stuff for just give me 2 minutes. In complex analysis, you can talk about like the nth roots of a number. So, for example, you can talk about the third roots of unity. The third roots of unity actually are, so there are three of these. You got 1, but then you also have, oh man, I can't talk about that here. Oh, yes, I can. Uno momento. Golly. I'm thinking. Okay, give me a second here. I believe we can do 1 plus I squared of 3 over 2 and 1 minus I squared of 3 over 2. What is this I? How does that work? Like, let's look at 1 plus I root 3 squared. How's that? When you square that, how's that work? So we just multiply like usual. It's 1 plus I root 3 plus I root 3 plus I squared times the square root of 3 squared. So you guys can tell me, what's the square root of 3 squared?
What's the square root of 3 squared?
3, right? Yeah. So what's I squared? Well, I didn't tell you this yet, but I is the square root of minus 1. So I squared is minus 1. So like this last term is actually minus 3. And what we've got is we've got minus 2 plus 2I times the square root of 3. All right? Then what happens if we multiply this by I plus root 3? So minus 2 plus 2I root 3 times 1 plus I root 3. What does that work out to? Minus 2 plus 2I root 3 minus 2I root 3. And what's that last term? We've got plus 2I squared, square root of 3 squared again, right? Oh, check that out. These terms cancel. That's neat. And this is a minus 2. This is a what? This is 3. That's minus 1. This is actually minus 6. So all told, we have, I believe, minus 8. Dang it. Oh man. I accidentally made a sign error. What I've showed you is the cube roots of minus 1 are minus 1. And, well, actually, what I have right here. See, what this means then is if we take 1 plus I squared of 3 over 2, and we cube it, if you look at this calculation, we've just showed that the cube is equal to minus 8 without the 2. So if you include the 2, you get 8 over minus 8. Minus 8 over 8, which is equal to minus 1. See, this number right here is a number that when you cube it, you get back minus 1. So with complex numbers, you can introduce additional cube roots beyond just like, we know the cube root of minus 1 is minus 1. You guys told me earlier today. Well, this is another third root of minus 1. And you can picture them on the unit circle like so. So this is the imaginary axis, this is the real axis. And so one of the cube roots of minus 1 is just minus 1. You know that one. This is the so-called principal. The principal cube root of minus 1 is just minus 1. That's the one we assume in here. We always calculate principal roots in this course. So the principal root of a real number is a real number. But there are additional roots. If you take complex analysis or a complex viewpoint, the ones I found for you are up here and down here. There's a perfect symmetry if you look at the circle, the way these are situated. If you wanted to look at like fifth roots, you could picture them. I can't tell you the numbers very easily, but the fifth root of minus 1, there's one here, there's one here, there's one here, there's one here, and there's one here. They come in these like symmetric pairs such that the angle as you sweep around is constant between any of these. It'll always be the case that if you add together all of the roots of a number, you get 0. Like the average of them works out to 0. They're always like symmetrically distributed around the unit circle. But anyway, if you're a math major and you take a course called complex analysis, then this is one of the things we'll do in there. Or abstract algebra, we also do it there. But anyway, for us, cube root, square root, we assume it is a real value, except the very end of this course, where we will take like square root of a negative number and use like, we do this at the end, right? Like square root of minus 3 is square root of minus 1 times the square root of 3, which is I root 3. Like that's the most complicated use of complex numbers essentially that we get to in here. It's pretty much just that. And we need that for the quadratic formula, so that's why we have to do it. Maybe I shut up, let you guys go.